Welcome back, guys. This is part 2 of the gravitational fields videos, and we're going to be working with this problem now. V404 Cygni is a dark object orbited by a star in constellation Cygnus. Many astronomers believe the object is a black hole. Suppose the star's orbit has a mean radius of 2.30 times 10 to the 10th meters and a period of 6.47 days. What is the mass of the black hole, and how many times larger is the mass of the black hole than the mass of the Sun if the mass of the Sun is 1.99 times 10 to the third kilograms? Let's draw a quick picture to see what's going on. So we have this mean black hole here, and then we have this unfortunate star orbiting around this black hole. You all hope this star doesn't get sucked in, but it may. But the point is, it's orbiting this black hole. Again, very unfortunate. But now, this should remind you of a certain concept that you've hopefully learned in physics. That's right, you guessed it, centripetal acceleration. The object is moving around in about a circular motion. I know this isn't circular, but it is circular. And we know that the centripetal force is always directed at the center of the motion. We know the acceleration is directed there too, and of course we know that the velocity is tangent to the circle. But now, this is an important connection that you guys have to make, and once you make this connection, it shouldn't be too bad from here. You have to realize that the centripetal force in this problem is actually equal to the gravitational force of this problem. You know, right? That's pretty cool. So based on knowing this, we can now substitute in equations. What does Fc equal? mv squared over r, and that's equal to g m1 m2 over r squared. Now hold on a second. There's a sub value for m here and m here, but this one has no sub value. Don't freak out, because if you remember from centripetal acceleration, that unit, this mass right here represents the mass of the object that is orbiting another object. So let's designate mass 1 as the mass of the black hole, which is what we're going to try to solve for. And then mass 2 will be the mass of the star. So in that case, we can put a subset value here of 2. Now we can cross multiply and solve for m1, which is what we're going to be doing essentially. However, we can make this easier on ourselves by crossing out some variables. If we cross multiply, because the terms are bounded by multiplication, I can divide both sides by m2 and they cancel out. So without even doing that, I can cancel out m2 right here, right off the bat. So I'm left with v squared over r equaling g m1 over r squared. Now another connection you should make. V squared over r represents the centripetal acceleration. So we're saying that g times the mass of this black hole over the mean radius squared is actually equal to the centripetal acceleration. That's pretty cool, isn't it? So we're going to try to solve for m1. Now we're not given the velocity, but we're going to come up with a general equation where we can sub in values easily and then obtain the answer. So first let's find the common denominator. This is r squared, right? So this is r. So the common denominator is r squared. So we need to multiply this by r. Whatever I do to the numerator, or denominator I mean, I have to do the same thing in the numerator. And because this is now r squared, when I cross multiply, the r squareds will cancel out. So I'm left with, let's come over here actually. We have r times v squared. Actually, that's not going to be enough room for you to see. Let me make it a little bit smaller. So we have rv squared equaling gm1. Now, like I said, we're not given the velocity in this problem. However, from the centripetal acceleration, we know that v is equal to 2 pi r over t. So we can sub that in for v. Now, I understand that's going to get a little bit messy, but like I said, by establishing this general equation here, we're going to find the answer. So let's square this. So we get r times the quantity. So 2 squared is 4, pi squared, r squared over t squared, and that's equal to gm1. Now I can distribute this r to this quantity. Now when I do that, I get, let's actually go to this board now, since we're running out of room, I get 4 pi squared r cubed over t squared, and that's equal to gm1. Now we almost have this general equation, so in order to get isolate m1, we have to get rid of g. Well, we can divide through g, or we could just do this, multiply it by 1 over g, which is the same as dividing by g. So whatever I do to one side of the equation, I have to do it to the other side. And when I do that, I get, we should put the r cubed first, since that's the higher degree, 4r cubed times pi squared over gt squared equals m1. There you go, guys. This is our general equation right here to solve for the mass of this black hole. So let's plug in some values that we know. So we have 4 times r is the mean radius. If we come over here, it is 2.30 times 10 to the 10 meters. Now, you don't have to include units here right as you're writing or subbing in the values, but do remember that you need to include units in your answer. So we're going to square this, and this is times pi squared, over g, which is a constant, times, now you gotta be careful here. You have to understand that when it comes to these type of problems, the units have to be consistent. This is in meters, and of course that's pi. However, t though is measured in seconds for this kind of problem, but it's in days, which is alright. So we need to get the number of seconds. So we have 60 seconds times 60, that's 3,600 seconds in an hour. Alright, there are 24 hours in a day. So that represents the number of seconds in a day, and we're told that the period is 6.47 days. So we're multiplying these 4 quantities, and then we're squaring that whole thing. Now this may look scary to you, but you have a calculator. And if you type these numbers in correctly, which you shouldn't have a problem with, we're going to get our answer. So I'm going to type this into the calculator, and you should too, and we're going to see what we get. Don't be afraid of the numbers in scientific notation, because after all, this is a black hole. A black hole is massive and has got a massive mass. Alright, so I just got it, and I hope you guys did too. I'm going to round this to the nearest 100. So it's going to be 2.30 times 10 to the 31 kilograms. That is our mass of the black hole. Now we're almost done. We have one more thing to do. We need to find out how many times larger is the mass of the black hole than the mass of the sun. So this is a good way of checking to see if our answer makes sense. If we take this number divided by the mass of the sun, which is what we're going to be doing in a little bit, the number should be greater than 1, or actually should be greater than 0, more or less. And if that's the case, actually I take that back. Never mind. Actually, I was right. If the number is greater than, say, 1, then you know that your answer makes sense to a certain extent. So let's do exactly that. We're going to take 2.30 times 10 to the 31st, and we're going to divide this by 1.99 times 10 to the 30th, and we get, let's see what we get. We get 11.58. And make sure you don't just leave it as 11.58. Make sure you elaborate on that so that you know and your teacher knows what you just solved for. So there you go. We know our answer makes sense because we noticed that this is a decimal right here, 11.58. We noticed that it is 11.58 times larger than the mass of the sun. And that number is clearly greater than 1, which means that not only is your answer sensible, but it also makes sense. So there you go. We just solved this problem, which took a while, but I hope you guys have learned how establishing a general equation and getting rid of variables will make this easier. So that's one tip for you guys. Like I just said, I'll reiterate. When it comes to these physics problems that involve, say, complex equations, I mean, this was not really complex, but it was a little bit. When it comes to that, try to find shortcuts. Now, of course, the shortcuts may not be there for every problem, but with some knowledge of centrifugal acceleration, which I believe all of you have, because you should learn about this after having a good knowledge of centrifugal acceleration, you can simplify this to a general equation like this, and you can simply plug in variables, of course adjusting units as necessary, to solve the problem. Thank you for watching this video, and I hope you guys have learned how to figure out the mass of a black hole, and hopefully this star will escape the black hole in the future.